Welcome back to Tyson Chem. Today we are going to focus on one of the most important reaction mechanisms of alkenes. So we're going to deal with the reactions involving alkenes. So reactions of alkenes. So alkenes undergo mainly two types of reactions. Number one, hydrohalogenation. Hydrohalogenation. Number two, electrophilic addition. The second one is electrophilic addition. So let us first start with the first one, which is hydrohalogenation. From the word hydro, here this hydro means hydrogen. So this part, let me just say hydro, just like hydro. This simply means hydrogen. Simply means hydrogen. Okay, and then halogenation. From halogen. So this one we can say halogen. Some they say halide. Halide. So if you add these, you have hydrogen here and the halogen. Halogen is denoted by X. So you have HX. So we are reacting alkenes with HX. HX. What is HX? So HX, the X part here represent halogen. So the X can be any halogen. This can be any halogen. We have chlorine here, bromine, iodine, or fluoride. Though fluoride is more, or you can say explosive, is more reactive, so that's not added here. So we have three: chlorine, bromine, and iodine. So this gives us to hydrohalogenation, reaction of alkenes with an acid. For example, we have hydrochloric acid, hydrogen bromide. Let us now focus on the reaction mechanism. A good examples. Let's just get a general alkene, any simple alkene like this one. So this is an alkene with a double bond. Let me put HX. X we know can be chlorine, bromine, or iodine. So what will be our answer here? A Laffer mechanism here. Let us first put this one HX like this. Here this X has some lone pairs, resulting into partial negative, and hydrogen here no lone pairs, giving us partial positive. But in here we have a nucleophile. We know double bond act as a nucleophile. So the nucleophile will attack an electrophile or a hydrogen here, expelling this bond. Okay, so the results here, we have definitely two results. We have a positive charge either on primary or secondary carbon there. So our results of something like this. This hydrogen can be added here with a positive charge on the middle here, or hydrogen there with a positive charge, a positive charge on this carbon. So which one is correct between the first one and the second one? So here, that's where now the law of radioselective comes in. So whenever you are adding an electrophile to a positive charge there, now you follow the law, which is what we call a Markov's condition, which states that hydrogen will go to where there are more hydrogens. So here, how many hydrogens do we have here? We have one hydrogen. What about here? Here we have one hydrogen. Here we have two hydrogen. So automatically the hydrogen will go here. So this is not the case. So now this is not the answer. Another reason which qualifies that the hydrogen should be on this carbon is that the positive charge there, carbocation, is only secondary position. This carbon which possesses a charge is on secondary carbon, because this carbon is going to another two carbon. That's why it's called secondary. And this carbon possessing a charge here, it is on primary, because it only have another connected to one carbon. So this becomes more stable, and this one less stable, or not stable. Let us use not stable. As a result, this one does not qualify, but the correct answer is this one. So the first one is the correct answer, because it follows Markov's condition, where hydrogen will be added to more hydrogen, and at the same time the charge is stabilized, or it is stable compared to the second one. So here your hydrogen is there and your positive here. Remember that this one, the X has been expelled. Here is our X with with lone pairs and a negative. So this one will just attack this one, the charge, the positive charge, giving us a product which is X, and this is our answer. So meaning it has followed the Markov's law. This one is anti-Markov's. This is Markov's. So this is the answer. Now let us go into main examples. Number one, let us get this alkene with HBr. What will be our answer? So automatically you can suggest that our answer will be something like this. Let's go through the mechanism. So you get the starting material. This is partial positive, and this one is partial negative. Now this one will act as a nucleophile, attacking the hydrogen, breaking this bond here, meaning our answer will be single arrow. Our answer will be hydrogen will go where there is more hydrogen. But if you check here, we have one hydrogen, there's one hydrogen, meaning automatically hydrogen can go here, or hydrogen can go that side. But if you check these molecules are one and the same thing. So you just get one of them, because this part is similar to this part and this one is similar to this one. So you just get one part. Let's get one part like here. So our positive charge will be there. Now we have eliminated this one, bromide. The negative charge. This now will come and attack this molecule here. So it can attack either from the front or from the back. So if it attacks from the front, meaning your product will be but if it attacks from behind, meaning another product will be so it qualifies to be called to have two products. Why are we having two products here? Some people may start wondering, why are we having two products? Why are we having two products in this case? We're having two products because this carbon here, it is a chylocarbon. A chylocarbon is a carbon connected to 3 different groups. So this is first group. Let me use another ink. First group, second, 4 different groups, third. So if you check here, this carbon is connected to 3 different groups. As a result, it qualifies to be called chylo. If it was connected to if it was not connected to 4 different groups, would have just have one product. But in this case, it's a chylo. It has a chylo center, meaning the hydrogen, the bromide, can either attack from front or from behind, resulting into 2 answers. Example 2. You are provided with this alkane, HCl. What will be our product? Our product will be okay. That's our product. So let us write the reaction mechanism. You get your starting material. HCl, act as a nucleophile, attacking that hydrogen, expelling the bond. This will give us a carbocation with a hydrogen here, the hydrogen and a positive charge there, following Markovnikov's law, where it says hydrogen will be added where there are more hydrogens. And your plus what? Plus Cl negative. Now your final product, now this one will come and attack here, resulting into this. That's your answer. Okay, what if you are given this wonderful alkane, then here HBr, then here also HBr, but in proxy as in a proxy, something like this. What will be our answer for the first one? So the first one will undergo Markovnikov's addition, or it will follow Markovnikov's addition. So your answer is the hydrogen, this hydrogen will be added where there are more hydrogens. Here, there are more hydrogens compared to there. So our hydrogen will come here. And the bromine will go where there is less hydrogens. Here is our bromine. That's our answer for the first one. For this, for the second one, this one in proxy. So this reverses the little thing now. This is what this will undergo and McCain-Coves or anti-McCain-Coves, meaning the hydrogen will go to where there's less hydrogens and the bromine will go where there are more hydrogens. So our answer here is this. So watch out this nanken, this solvent which has been used here. So in other cases, R or we can say it is having same effect as H. So R or R with H2O2, they are having same effect. So if maybe you have been given a structure like this one, it's a double bond there, then they have given you this and the H2O2, meaning here they are telling you that this should undergo anti-McCain-Coves coefficient. So you have your iodine here and your hydrogen here, because this they're having same effect. Okay, let us go to another example. What if you have been provided with this one, hydrogen chloride? What will be our answer? Now here you should be very careful. Okay, let us do mechanism first for you to understand better, because the answer is different from what we expect it to be. So now the hydrogen, the nucleophile there will attack the hydrogen, expanding the bond here, meaning you have your product here. Follow the first step, which says more hydrogen will be added to where there are more hydrogen, our hydrogen here with a positive charge and a chlorine. That's the first step. Now the second step here, we don't just add the chlorine here, no, because this is what? This is a secondary, the carbon having a positive charge, it is on secondary. So let's denote this by saying this one is having a positive charge on secondary carbon. But we can, and here we have hydrogen, we can have a hydride shift or hydrogen shift. This hydrogen can shift from this position going to the second the secondary carbon here. That will qualify to give us an structure like this. This hydrogen, or let's start with this one, it is the same one which is here. Now this one has shifted from the tertiary to secondary. So here your hydrogen it is the same one, which is this one, and the charge is in here. Now the charge here, this charge on the secondary and the charge on tertiary. So this one is more stable. Less stable. So automatically this will be your major product. The one with positive on tertiary will be our major product. So now you get your chlorine now, and attach here. So your answer will be the chlorine here. So this one will be major product. And this one will be minor. But in some other cases, if they ask just for one product, please get this one and not this one. Okay, now at your free time, please do the following questions. Provide the reaction mechanism, and also follow the step clearly on formation of carbocation ions. That's number one. Number two, hydrogen chloride. Number three, so you can now provide the answers for starting from question 1 and from question 1 to question 4 using the steps that we have already discussed. If you find this video useful, please remember to subscribe to my YouTube channel. Shalom.